Hello everyone, this is Dr. Zach. It is time to prepare for your test on convergence and divergence. How do we begin? You would first need to look at your series and decide which convergence test is best to use. For each series, test to see if the nth term approaches zero. If your nth term does not approach zero, you immediately know that your series will diverge and your problem is over. If it does approach zero, next check to see if it's a series you recognize. Is your series harmonic, geometric, a p-series? Could it be telescoping, or is it alternating? Maybe you have to use the alternating series test. Use your integral test when the nth term is easily integrated. The ratio test is best used for functions that increase rapidly, like exponentials and factorials. Can you tell which series can be compared favorably with one of these special types? Perhaps the limit comparison test is best. All the tests have been listed with their conditions for convergence and conditions for divergence. Take a look at the comments. The nth term test cannot be used to show convergence. For your geometric series, remember that n equals 0, 0 gets substituted in for the exponent, you must get 0, otherwise you're going to have to solve for the first term to use your summation formula. Your telescoping series might be disguised as a ratio. For your p-series, this is your best series to use when comparing. Your alternating series test. You have two items that you have to show before you can use your alternating series. Ratio and root tests are super fabulous. Make certain you've practiced and can use those as well. For your mixed practice, questions 1 through 6, choose which test is going to be best to determine if these series will converge or diverge. So let's look at example 1 and example 2. For each series, we're going to determine the interval or the values of x that would allow our series to actually converge. To do this, we're going to use our ratio test. So for example 1, we write the limit as n goes to infinity, as that's our test for convergence. We will have the absolute value, 3x minus 2 raised to the n plus 1 divided by your 3 times x minus 2 raised to the nth power. When we simplify, we have the limit as n goes to infinity, the absolute value of x minus 2. Now, in order for our series to converge, the ratio test says this must be less than 1. So let's take a look at this interval. We will have absolute value of x minus 2 is less than 1, negative 1 less than x minus 2 is less than 1. So x is trapped between 3 and 1. Now, those are the x values for which our interval will converge. But it is possible that the endpoints should be included. So we're going to have to check to see about the endpoints for each one of these problems. For the first part, we're going to let x equal 1. We will substitute the x value into our original series, and that gives us 3 times negative 1 to the nth power. Now, negative 1 to the nth power is just alternating the number 3, and that limit as n goes to infinity does not exist. So at x equals 1, we do not have convergence. So we're not going to include 1 as an endpoint. Let's check out 3. When x equals 3, substitute 3 into our series. We have n equals 0 to infinity. 3 times 3 minus 2, which is 1 to the nth power, which is 1. If you keep trying to add 3 over and over and over again, this again does not converge. It will diverge, in which case our final answer is we will have convergence on our interval 1 less than x is less than 3. Let's look at example 2. So for example 2, again, we're going to use our root test. We take the limit as n goes to infinity. We have the absolute value, x to the n plus 1 over n plus 1 multiplied by the reciprocal n over x to the n. Simplify our problem. The limit as n goes to infinity, the absolute value of x is going to be less than 1. So again, we will only have convergence when absolute value of x is less than 1. Let's solve this. Negative 1 is less than x is less than 1. We must check those endpoints. Make it obvious. If you do not make it obvious, the graders will not give you credit. So check your endpoints. You're going to let x equal negative 1 to start, which will then give us the series from n equals 1 to infinity, negative 1 raised to the nth power over n. You should recognize this as your alternating series, alternating harmonic series, and it, of course, converges. Next, we'll let x equal 1. Substitute, we have the series n equals 1 to infinity, 1 divided by n. And this, again, is your harmonic series, but it's not alternating, so it diverges. Your final answer for the interval of convergence, so you have interval of convergence, is going to be negative 1 is less than or equal to x is less than or equal to 1. So you must check your endpoints whenever you are looking for the interval of convergence. Next, try questions 7 through 11. Check your answers once you're finished. Questions 12 through 15, you are trying to determine your intervals of convergence. Remember to use your ratio test. So for the first one, you take your limit. As n goes to infinity, you have the absolute value. I'm going to leave the alternating series component out, which gives us an x to the 2 times the quantity n plus 1 divided by 2 times the quantity n plus 1, and that gets a factorial multiplied by the reciprocal, and we will have 2n plus 1 factorial divided by our x to the 2n plus 1. Now we're going to simplify. We get the limit as n goes to infinity. The numerator is going to be x to the 2n plus 3, and that leaves us with x squared in the numerator. Your denominator is, again, 2n plus 3 factorial, so we will have 2n plus 3 times 2n plus 2. Then 2n plus 1 factorial will cancel with the numerator. We will next take the limit as n goes to infinity, and as we go to infinity, the answer for this, it was n goes to infinity, we get 0. And what that tells us is that we will converge for all x values, and that means your interval convergence goes from negative infinity to positive infinity. Don't forget, for questions 13, 14, and 15, you do need to check your endpoints.